In this third video for Chapter 2, let's discuss hydrophilic and hydrophobic substances. Then we'll skip ahead in your book to oxidation and reduction, and finish up with acids and bases. We're going to stay with the topic of water forming hydrogen bonds for a moment. Substances which are attracted to water are hydrophilic. They're hydrophilic because they contain some polar covalent bonds and will form hydrogen bonds with water. The opposite, hydrophobic, is repelled by water. These hydrophobic substances are held together by mostly nonpolar covalent bonds, and as a result will not form hydrogen bonds with water. Sugars, for example glucose pictured here, have lots of polar oxygen-hydrogen bonds. We've got 1, 2, 3, 4, 5 polar covalent bonds here. As a result, they'll form lots of hydrogen bonds with water and typically dissolve easily in water. In contrast, lipids, like the fatty acid pictured here, contain almost entirely nonpolar covalent bonds. Carbon-carbon and carbon-hydrogen are both nonpolar. Water molecules will form hydrogen bonds with each other and will push this hydrophobic oil away. Jumping ahead in your textbook, I'd like to next cover oxidation and reduction. Oxidation occurs when an atom or a molecule loses one or more electrons. Reduction is the opposite. An atom or molecule is reduced when it gains an electron. These two reactions are usually linked and are often referred to as oxidation-reduction reactions. If the transfer of electrons was all that was involved, I probably wouldn't mention oxidation-reduction in this class. But something else is also being transferred with the electrons: energy. That transfer of energy is very important in metabolism used by living organisms. Oxidation is the result of an atom or a molecule losing electrons and losing energy. For example, the release of energy from your food often involves oxidation. When a molecule or an atom is reduced, it gains electrons and also gains energy. In this reaction, NAD is the lower energy, the oxidized form of the molecule. Adding electrons and energy, also a hydrogen ion, produces a reduced, higher energy molecule, NADH. NADH is somewhat like a rechargeable battery that stores energy in your body. NAD is the discharged, the low energy form of the battery, which has released its stored energy and its electron. Switching topics now. An acid is a substance that releases hydrogen ions when mixed with water. Hydrochloric acid is a strong acid because it releases hydrogen ions when placed in solution. Bases do just the opposite. When mixed with water, bases remove hydrogen ions from the solution. Or in the cases of bases like sodium hydroxide, they release hydroxyl groups which combine with the hydrogen ions. pH is a measure of how acidic or how basic a solution is. It's actually a measure of the hydrogen ion concentration of the solution. 0 is the most acidic, with lots of hydrogen ions. At the other extreme, 14 is very basic, with very few, almost no hydrogen ions. Halfway between 0 and 14, 7, is neutral. It's neither acidic nor is it basic. Coming back to our definition of pH. More correctly, pH is the negative logarithm of the hydrogen ion concentration. Don't freak out on me. We're just going to use this to explain a couple of things about pH. First, where do 0 and 14 come from? Remember exponents? Remember 10 to the 0 power equals 1? Think of that 1 as the whole thing, as many hydrogen ions as possible. I don't even know what to call 10 to the minus 14, but it's a really small number, almost 0, as in almost no hydrogen ions. One more thing, because we're working with exponents, every whole number change in pH represents a 10-fold change in the hydrogen ion concentration. That wasn't too bad, was it? It's very important for organisms to be able to control pH in their bodies. Buffers help to maintain a constant pH. They do so by combining with hydrogen ions when mixed with an acid. They do the opposite when mixed with bases. In response to the lack of hydrogen ions, they release more. Please note that adding a buffer does not necessarily mean the pH will be neutral. Some buffers maintain acidic pHs and others maintain basic pHs. Whew, that's the end of this video.